Hey guys, welcome back to the channel. This is Robin Williams with yet another challenge lab for you. Right, today we've got a little interesting lab. It's a very fairly simple one, talking about access control lists and also enabling telnet for users. So what we have here are three devices, R1, R2 and R3. No fancy names today. What we're going to do, we're going to configure the lab so that the following conditions are met. We're going to enable telnet access onto R1, and we're going to use a password of Cisco 123 for that. We're also going to ensure that the telnet users are able to enter a privileged exec mode when they come onto R1. So that means they can telnet in and basically administer the device correctly, like a full level 15 user would be able to. For security reasons, we're going to ensure that telnet users on R1 are logged off if they're inactive for more than 5 minutes. Basically, it means if they walk away from their desktop and they're logged into a session, they'll come back. If they're not used the session for 5 minutes, they'll find themselves logged out of R1. Then what we're going to do, we're then going to ensure that when we ping R1, that we from R2, okay, so R2 will ping to R1, and we're going to ensure that R1 drops those packets, okay, but at the same time, R2 should still be able to telnet to R1, and it should also be able to ping across here to R3. Okay. We're going to test that R2 can ping that physical loop, the loopback address on R3 here. Also, we're going to allow R1 to be pinged from R3, but R3 is not going to be able to telnet into R1. Okay, so we'll write an access list to stop that, and then R3 will block pings from R1 to its loopback address, but it will still allow pings to its physical address. Okay, and then R2 should still be able to reach the loopback of R3 as well. So basically the loopback should still be available. So without any further ado, let's get into the labs and let's see what we're doing. So the first thing we need to do is enable telnet access. So you do that by going into the conf mode. Okay, and then you've got to look at your lines. So we're going to look at line VTY04. Okay, so now you're into line configuration mode. We're going to first off, we're going to configure the timeout. So that's called exec. Okay, timeout. So you can see the command here, exec timeout. Yeah. So exec timeout, and then if we hit a little question mark, it'll show you it's got the time in 5 minutes there. So we're just going to put 5. Okay, and then 0 because it's got the timeout in minutes there as well. So that's 5. That would basically mean that if you're away, don't use the system for 5 minutes, it will log you off. Okay, we're then going to create a password on the line. Okay, and I believe we wanted the password to be Cisco 123. Okay, and then we just choose login. Okay, so let's just test that and see whether that's working from one of the other devices. So if we go to R2, okay, and we telnet 192.168.1.1. Okay, there we go. We put in our password, Cisco 123. That's all good. Now, if we hit enable now, we get a no password set. So currently, we're unable to enter the privileged exec mode. If I go back to R1 itself, okay, exit out. It's a really simple way to do this. All you do is enable the secret. Okay, and I'm just going to put a simple password in enable secret Cisco. So now if I go back to R2, it's now asking me for the password. And there we are, we're into privileged exec mode. Now as you can see, we're on router 2, but we've telnetted into router 1. So we're just going to exit out of there now. Okay, and it closes it off. Okay, so that is the first line of the lab challenge done. Okay, well, the first 2 lines. So the next thing we're going to do is we're now going to configure R1 so it drops pings from router 2 but it does allow telnet still from router 2. So let's go on to R1 again, and we're going to have to write ourselves an access list here. Okay, so I'm just going to copy and paste this from what I've done before, and I'll run you through the instructions of what I'm doing completely. Okay, so here we write an access list 100, so we're naming it. Then we put in the deny statement to deny whatever happens, ICMP for ping, and then we say from this host 192.168 towards host 192.168.1.1, which, so the basically, if I just make this a little smaller for a second, okay, what we're saying there on this command is when the host 192.168.1.2 sends a ping packet across to 192.168.1.1, that packet will be dropped. Okay. Now we're also going to ensure that we're going to do the same for this interface, which is 10.0.0.1. So then R2 cannot ping either of these two. Okay. In fact, before we do that, no, actually, let's do that as well. So we're going to add in another line to the. Okay. So it's the source. Access list 100 again. Deny ICMP, which is the type of traffic from the host 192.168.1.2 going towards what did we say, 10 dot, I believe it's 10 dot, is it 10.10 or 10.0? I can't remember. 10.0. Okay. .0.0.1. Okay. Sorry, you should have put in there host 10.0.0.1. Okay. So that will now block pings from either side. What you've also got to do, remember at the end of any access list there is an implicit deny all. Now access lists are read from the top down, and as soon as a match is found, that's when they stop reading the access list. So what we do now, go back into the access list, we hit a permit to allow traffic IP NA. So that basically says if the top two statements aren't matched, let everything through, and that then deals with the implicit deny at the end of the statement. Okay. What we next need to do is we need to apply this access listing. So we go to the interface, FA fast Ethernet 0/0. Okay. And we basically now apply the access listing, and we do that by using access group. So it's IP access group, and then we put in the access list number, which was 100. Okay, and we decide which direction we're going to put it. So in our case, we want to deny the packets coming in. Okay, so now if we go back to R2, okay, and we try to ping we now get a host unreachable with a success rate of 0, and we'll just try the other device as well, the other interface I should say, and again we get a host unreachable. Just to prove there's no magic tricks taking place, if I go across to R3 at the moment, and try to ping the same interfaces, we get a response back. So at the moment, you can see that we've denied all traffic from R2 being pinged across to R1. Telnet traffic will still work. Sorry, that's the wrong device. So if I go over to R2 again, and I telnet across to 192.168.1.1, you see we're still getting the prompts there as well. So we know that the telnet traffic is still working. There we go. Get rid of that. So we know the telnet traffic is still working, but we've denied the pings across to there. Okay, so that's fine. So that is basically that line there done. R1 drops pings from router 2, but does allow telnet from router 2. Okay, we've tested that we can ping everything else. So R2 just needs to test we can still ping the loop back on R3. So let's just have a quick look at R3's loopback address, which is 3.3.3.3. And if we just go ping, you can see that it can still traverse the network. So the ping packets are able to move through here from R2 through R1 and into R3's loopback interface. So putting the access list on only drops the traffic to which is specified in the access list itself. Okay, so next we've got a R1 will allow pings from R3, but it will deny telnet access. So we go back to R1. I'm just going to expand it a bit. Well, not quite that big. I'm just going to make the screen a little bit bigger for you. Okay, so we need to write yet another access list. So we're going to write access list. We'll go for 101. Okay. Now this is a deny statement because we're going to deny something. So we deny TCP because it's a TCP application. Telnet is. Okay. So the host. Now traffic from here would become from 10.0.0.3, which is the interface, the physical interface on the R3. Okay. Okay, so command here, access list 101. We write the access list. We're denying the traffic from the TCP host 10.0.0.3. We're going to deny telnet traffic from this host to anything. So it's any equal to telnet. Okay. Again, to allow pings, we now need to do access list, and then we have to permit any. Okay, and that then takes care of the implicit deny at the end of the statement. Okay. Sorry, it's permit IP any, isn't it? Okay, so that allows any other IP protocol not caught by this statement here to then be allowed through the device. Okay, now you might be wondering, where do we apply this in access list? Remember, with access lists, the rule are you can have one access list per direction per interface. Now we want to stop traffic coming in. We've already enabled an inbound access list on the fast Ethernet 00. And really what we're interested in is stopping traffic coming in here. So we're going to apply this interface, this access list to interface fast Ethernet 01. Is it FA10? Sorry, yeah. And again, it's IP access group 101, and we want to apply it on the inbound. Okay, so what you'll see now, if we go to R3, okay, is we can still ping (10.0.0.1), but if we try to telnet to 10.0.0.1, it says the host is unreachable. Okay, and just to check that we couldn't get onto the other side, which is 192.168.1.1, 1.1. Again, we get the same issue. But if we try to ping it, we know it's up because we're getting responses, so we know that it's being blocked by our access list. Okay, so that's all good. We've now denied telnet access from 3 to 1, but allowed the ping access through to go through. Okay, so that's this line here done. So now R3 needs to block pings from R1 to its loopback address, but still allow pings to its physical address. Okay, so what we need to do is we need to add another line into that access list on we need to create an access list on R3, sorry. So we're just going to fire this up now. So we go into configuration mode. Okay, it will be access list 100 deny density deny ICMP again. Now we're blocking from router 1 192.168.1.1. okay, and we want to block it just going to the loopback address. So we just specify here the host address that we're interested in. So access list 100 deny ICMP, which is ping, coming from the host 192.168.1.1, destination host 3.3.3.3. Okay, what we're also going to do, okay, access list 100 deny ICMP host, because router 1 has two interfaces, okay, 192.168.1.1 and 10.0.0.1. we need to create a line for both interfaces. So we're doing exactly the same, but we just specified a different host address to start with, and then the destination address is the same. So we're just specifying a different source address here, and we're keeping the same host. Okay, now because we've already got this on the interface, it should work straight away. Let me just have a quick look at the we need to, in that case, apply it to the interface. So it's IP access group, name of the access list, which in our case is 100, and we want to apply it on an inbound direction. Okay, so now what we should find is that when R1 tries to ping the loopback of R3, it's denied. So let's just try that. What I did forget to do there was a schoolboy error on that access list. I forgot to put in the. Let's have a quick look. I believe I've forgotten to put in the allow any NA. Let's have a quick look. Yeah. So what I need to do is go into the access list. Because you saw the EIGRP relationship fall down, that was because they deny any NA, and now you see the EIGRP relationship come back up. So let's just have a quick look at that now. Just check we've got our EIGRP neighbourship up. Yep, and as you can see, it's just come back up after I put the allow statement into the access list. So if we now go to R1, okay, and we try to ping 3.3.3.3, we get denied. Okay, but if we try to ping 10.0.0.3, oops, can't say that, sorry, it's permitted. So that's how we've blocked access to that loopback interface as well. Now, the final thing we need to do is we need to just confirm that R2 can still be able to reach the loopback of R3. So whilst R1 can't reach it, R2 should still be able to reach it because there's nothing specified in the access list denying R2. So let's just try that then. We ping 3.3.3.3. There you go. We're able to hit the access list. So that's a very brief demonstration of access lists and also a very basic configuration of telnet as well. Hope this has been useful to you. There will be more labs coming up soon, so please hit the subscribe button when you're ready, and I look forward to seeing you soon, guys. Thank you.